Ethereum's next upgrade, Dencon, is a rollup centric with EIP 4844 as the anchor EIP. If you want to learn about other spec changes, especially on the consensus layer, stay with us. Welcome to PEEPanEIP episode 111. Today, we will make an effort to keep up with the Deneb spec changes with a very special guest. I'm your host Pooja Ranjan from Ethereum Cat Herders, and I'm very excited to invite someone who is a client dev for Lodestar, Ethereum JS, and a core EIP editor to help us with the EIP process improvement. Welcome to our own Gajinder Singh. Thank you for joining us.
Thank you, Pooja, for inviting me.
Gajinder Singh has been kind enough to have joined us on PEEPanEIP to talk about the Lodestar client, Ethereum JS client, and EIP implementation in earlier upgrades. And today it is about a Deneb upgrade. I'm aware we have got a presentation to be shared, but before that, may I request to briefly introduce yourself to our new users?
Thank you, Pooja, for inviting me to talk about Deneb. And hello, everyone. I'm Gajinder, and I work on Lodestar and Ethereum JS. Lodestar, as you would know, is a consensus client in TypeScript, and Ethereum JS is an execution client. It's an experimental client, but it's backbone of the JavaScript TypeScript Ethereum ecosystem. And today we are talking about the next upcoming hard fork Deneb, which is primarily focused towards rollups. So it's increasingly clear that the road to Ethereum scalability is based on enabling rollups, which is sort of part of the surge roadmap. And 4844 blobs are stepping stone for that, because the blobs that are being used in Deneb, which is basically defined in EIP 4844, they are of the same format as what is planned in sharding. So what this hard fork really introduces is that a transient data without permanently blowing up the blockchain. So you have a blob which is made up of points, and each point is basically a roll-up data vector. So roll-up can decide what that point is. It could be a it could be a roll-up transaction, it could be roll-up state changes, or whatever roll-up really wants. Ethereum is not really concerned about it. But what does Ethereum provides is that some data point, one can refer to that particular blob in smart contracts and see whether a point in that blob was included or not. So with a very succinct proof, one can figure out in the smart contract whether a particular thing was included in the blob. So for the CL, what it really means is that there is now a block, and then there are blob sidecars for every slot in Deneb, and a blob sidecar has blob data, it has commitment and proof. We'll come to what commitment is later. And now you have 6 blobs per block, which is max. So basically there is a target of 3, but you have 6, and this target and limit might be revised later. But what it really gives is basically a little less than 1 MB of data space per block. And for the sharding, the target is to go up to 16 MB per block. And the good thing is that all this data is never going to be permanent part of the blockchain, so it's transient. What it really means is that in basically around 18 days, which is 4096 epochs, this data will get cleared from the clients. So one has to take this into consideration, that this is just a transient storage. And what Ethereum blockchain really makes sure is that the blob data was available for on this particular period, so that one is sure that whatever is included in finalized, that data was available. What it really means for execution layer is that, so the question arises, how does the blob data enters the network? So then there is a blob transaction. So what a rollup would essentially do is it would create a blob transaction and basically pair it with blobs, commitments, and proof, and send it to an execution layer, which would only include the basic transaction. It would not include blobs or commitments or proofs inside the execution payload. So the execution payload transaction, the serialized transaction in an execution payload, would be a shorter version of the real blob transaction. But execution clients will provide blobs bundle to the beacon clients while they are requesting a proposal. So what the beacon clients would then do is that they would transmit the block which has this execution payload with the shorter serialized blob transaction data along with blobs, which are basically independently transmitted. All this is based upon KZG cryptography, and what it really means is that blobs can be mapped to a low degree polynomial. So, which basically simplifies proof verifications for 4844 data availability. And I mean, right now in 4844 in Deneb, these verifications are quite simple, but when we'll go to the sharding stage, there will be custody proofs and there will be sophisticated data availability checks, because the validators will be divided into different shards, and different shards will be responsible for making sure the availability of the data that is allocated to that particular shard. So what are sort of blob polynomial hashes? So each polynomial is sort of uniquely represented as a commitment, and one can think that how we would hash the data, we are hashing the polynomial, but indirectly we are also hashing the blob. So each commitment is basically uniquely representing a particular blob. What this enables is that one can in EVM, in smart contracts, can verify whether a particular point in the blob was included in the blob or not without having the full blob, right? So execution layer. So as you know that, as we have discussed, that blob data is not really part of the payload serialized transactions, but one can still verify using proofs and using this particular blob hash of code that whether and point evaluation pre-compile, which has been added to EVM, that whether a particular point was in that particular blob. So you can use it to verify whether a particular data point was in the canonical chain. So basically, needless to say, we have come a long way for the development of these blob features. And initially, Prism and Get were championing this particular feature, and around DevNet 4, other clients joined in. And there have been tons of iterations on this. And so some of them are like, we started with blobs which were tightly coupled with the blocks. So we had a container in which both block and blobs would be there. We have now moved to the spec, which is more closer to sharding, in which basically blobs are totally decoupled from the blocks and they are independently transmitted on the network. Data availability checks were earlier part of state transition, and now they have moved to fork choice, which basically allows clients to sync the blocks without blobs, without making sure that there are all blobs, but somehow in a sophisticated manner, then they would have to make sure that the data for the block that they sync that was available. So they will have to sort of collate it in their fork choice. But right now, how clients are doing it, it's in a simplified manner that they would not import a block without the blobs. Another change that we have seen as part of the iteration of this hard fork is that blobs were earlier SSD based, but there was a lot of discussion which went among the developers, and it was decided that SSD, there is no need to introduce SSD as of now, because there are parts that should be touched by bringing SSD into fold, which was not really happening. So it was like half-baked effort, which no one really wanted. So it was then again transitioned to RLP format. And we are again seeing some churn on what is the max number of blobs per block that should be allowed, because it is a big thing. So a blob that you get from P2P is not really, you don't really transmit it. It's not singly transmitted. So as many peers as you have, you might be doing P2P gossips of the blob. So it has really big impact on the bandwidth, and it might affect the decentralization, because small stakers and home stakers might not have that level of infra support. And so there is some discussion going on what is the max blobs that one might require for this particular hard fork. And obviously, when we'll go to sharding, we'll again have to revisit this problem again. And hopefully there could be some sort of solutions which like super block builders, which can help in all of these things. But that is something to be done and figured out on the later stage. Another thing that we basically iterated on this particular hard fork was we changed KZG cryptography from little endian to big endian, which basically impacts how a smart contract would bundle the data to the pre-compiled inputs, as well as how a blob and network format transaction of the blobs is being packaged. There were some other nice things that happened, which was basically there was simplified computation format for access data gas and data feed. And then some of the other simplifications were added by introducing some validations that, okay, a blob transaction will not be able to deploy a contract. So there has to be a destination address, and then one can't do a blob transaction without actually having any blob. So as with every other hard fork, things change. And however, with blob, few things change in fundamental ways. So one of the basic thing is that, right now, everybody on the network already is using checkpoint sync to start their nodes or to, bring their left behind nodes up to date to the network. But you can still theoretically start from Genesis and sync forward your beacon chain, and basically taking into account long range attacks and all that, right? So that is still possible, but with this particular hard fork, it won't be possible because the blobs won't be available before this particular 18 to 19 days window of blob availability. And so one will be forced to use checkpoint sync because the nodes will be stalled if you start before this particular window. And then there is extra space requirement, which could be 60 to 100 GB or maybe a little bit more, depending upon what is the limit that we put on max blobs per block. And obviously there could be a very big concern and impact on network bandwidth that might be required for running a client, which is basically more serious concern that the community is debating about. And what other impact? So Web3 Signer API will need an extension. So all these third-party apps, they will need an update. And then one also will have to consider that there is increased traffic between validator and beacon for proposals because the blobs are also being passed around. And then one will also have to sort of account how they would set up their network to make sure that any latency doesn't show up while the proposals are happening. And obviously now you can't really import a block without basically, making data availability checks on the blobs. So it basically, there is potential for increased latency that would imply tighter schedules for proposals and attestations. And obviously the builder and MEV proposal flows will also be impacted. And they will also have to provide the blinded versions of blob sidecars, and the validators will have to sign blob sidecars, and then the blinded versions will be published to the builders and relays, and the rest of the things will come together. So the progress so far is that we have so there is an ongoing DevNet 6, and which is basically all 4844 focused. And we might have another DevNet, which could be 4844 focused because some of the clients are just catching up with all the spec changes that have happened. And then there is an ongoing testing for what is the max blobs that can be supported without really hurting decentralization. And once the 4844 spec is sort of stabilized, once the clients get stabilized and we have stable DevNet, we will move to include extended Deneb features. And coming to those features, so some of the features that are candidates are EIP 4788, which is basically including a beacon block root in EVM. So one would be able to now do proofs for the beacon state in EVM. So for example, if someone wants to trigger withdrawals or someone wants to trigger exit, they would be able to do it. So basically this will enable a host of applications and host of activity on beacon activity that is primarily happening right now on beacon chain. The trigger would move to execution layer where how one would just normally interact with a contract, and it would trigger things on the beacon layer. Another EIP that is being considered is basically having perpetually signed voluntary exits. Right now, what really happens is that if you sign a voluntary exit and for some reason you retained it, you didn't transmit on network, basically it would get invalidated if there is a new fork. And since there is no real need to invalidate it, it is being simplified that post Deneb, whatever you will sign, it will be perpetually valid. And it will enable applications where people would want to not transmit it right now, but to have these re-sign and just retain it and maybe transmit at a later stage. And on Engine API, some simplifications are being made where exchange transition configuration endpoint is being deprecated because an Engine API methods will be one-to-one mapping with the hard forks. which will basically simplify some of the validations that happen on the execution clients when the requests from beacon clients come through Engine API. And then there is another EIP 7045, which proposes to increase max attestation inclusion slot right now. So attestation can be included up to 32 slots for a block. And what it really proposes is that attestation for a particular block be allowed to be included or to be allowed to be included till the boundary of the next epoch. So this will sort of give some extra goodies like, it will improve security proofs as well as it will allow confirmations in approximately 3 to 4 slots in normal mainnet conditions. And then there is another very interesting topic that is being discussed and might not or may be part of Deneb, might or might not turn out to be part of Deneb, is to sort of increase max effective balance. So max effective balance is the balance on which one earns the rewards, and whatever is above the max effective balance is, if you have enabled withdrawals, it will be withdrawn out to your execution address. So what really happens is that right now small stakers are on a disadvantage. There are whales who can basically pool their rewards together much faster and then start another validator. But for example, someone running with a single validator, they won't be, for example, for 5 to 10 years, they might not be able to start another validator with the rewards for that. So they might not earn any rewards on whatever ETH they have accumulated as a result of staking. So it might balance the scales between a small staker and a big whale. So that is something I think is interesting and very useful for small validators. So that basically covers what all things are right now happening in Deneb. And but this is not an exhaustive list. Most things could come in and things could change. So, but we are moving towards a point where the spec is more and more stable.
Sweet. Thank you. As many of us know that the main goal of this series is about creating awareness about anticipated protocol changes. So it was really nice to follow some of the less popular, but I guess high value changes, which is expected with the Deneb upgrade. So thank you so much, Gajinder Singh. You have brilliantly explained changes with the help of this presentation. And I hope the information shared today on spec and EIPs will be helpful to many others like me. And I will also try to get respective EIP authors on this show to have a deep dive into proposals, the CFI proposals. Overall, it was a great summary. The next section is about question and answer. And my first question is with respect to the proposals that you have just shared. So I wonder, some of the proposal is not even in the merged as a draft status, 4788 is already on the CFI list for Cancun, but EIP 7044 and 7045 are not. I'll be willing to pick your brain on how you see the EIP process evolving for consensus layer. And is the process a bit different than EL clients? Like I imagine the spec change with respect to proposal is already merged in the consensus specs. However, we are still in the process of documentation. So yeah, if you can maybe explain how does this work?
I think primarily it should not be really different, but what is really different between execution layer clients, developers and consensus clients developer is basically, the discipline with regard to the EIP process. Execution client developers are more familiar with EIP process, and of course there are some hurdles like we have issue with what links to allow and all that. So there are some bureaucracy around that, but hopefully we are trying to resolve it so that people, the developers can feel quite easy to write an EIP because they are already doing all the hard work by writing the consensus specs. So writing an EIP out of it is not really difficult, but yes, it takes a bit of familiarity with the EIP process because as being as a part of EIP editors, I have come to appreciate that this is something that the entire world is looking at. And so the quality of the EIPs, or even if they are draft, they have to have some standards. And even though we'll try to make sure that, we can basically address some of the issues that the developers are pointing out. But all those issues will only come forward when consensus client developers will use it and bring to our notice whatever difficulties they are facing. So then I would like to only mention that, we are happy to resolve whatever issues they are facing, and so that the process becomes smoother and smoother.
That is true. I mean, like I agree that the EIP process is relatively new for consensus client. I suppose in due course of time, they would get more familiarized and be able to follow the process as it is for EL clients. Another question about this EIPs. I see there is this proposal which does not seem to be a part of EIP, that is with respect to engine API. Should we expect a proposal for that as well, or do you think that it can go as just a spec change and no EIP would be needed for it?
I mean, it's part of the engine API repository, and it's not really basically a change in terms of design or in terms of a new idea that is being proposed or modified, right? It's just an implementation detail, but I'm not sure whether it should come even in the EIP or not, because EIP is where, we have this repository of the ideas that are going in implementation, and then there are some nitty-gritties and details, implementation details, which are not really concern of EIP process, in my opinion.
Yeah, it makes sense here. So I understand that this could be a consideration at the time of testing, probably not being a part of EIP, because EIP is anyway a standard that is made available for client teams to follow and implement in their respective client. Yeah. My next question is with respect to engineering challenges after the Capella upgrade. So after Shanghai and Capella, this is the first network upgrade where we are making changes with respect to withdrawal process, or when we have fully enabled the withdrawal process. What were the engineering challenges that could not be addressed with Capella or could have occurred after that we are trying to address here with Deneb?
I think with Capella, more or less, things are running quite smoothly, and things are going fine. I don't really see that, we are trying to address anything that was missed in Capella. So this hard fork really, in a big way, focuses on totally new features. And in my opinion, we did a good job with Capella.
That's always wonderful to know, that we are not trying to fix anything that broke in the past with the past upgrade, but we are just trying to improve it. I'm so happy about it. All right. Moving on to the DevNet, we get to learn about the DevNet 6, which is there for EIP 4844. And as you mentioned, like when DevNet 4 was there, then most of the clients joined the development work. I've seen you engaged with testnet earlier as well, like when Shanghai was there, you were involved with Shandong testnet. So I'll be curious to hear from you. What do you think about Deneb or Dencon testnets? If you're allowed to maybe alpha leak, when can we expect a DevNet for Deneb or Dencon?
I mean, the DevNets are already running, but if you mean a public testnet, then I think we are like maybe a month away from it.
Yeah, I was just curious to understand the present DevNet 6 that we are talking about. Does it include any other proposal or just the 4844? And if it is just the 4844, do we expect a DevNet with all the proposals in?
Yeah. So DevNet 6 is basically 4844 focused only, but right now, not all clients are stable in terms of, making proposals, in terms of downloading the chain or serving the chain. So we are seeing issues in which one client also included a transaction in the network format, basically with the blobs, which is not how it's supposed to be in the execution payload itself, right? So we are seeing these kind of issues, and but these are getting resolved, and all the client developers are working on it. But I think there will be another iteration of 4844 focused DevNet, and maybe 2 weeks after it, we can see next DevNet with the extended Deneb features that I have mentioned on the list.
That's interesting. My next question is with respect to the blob and the blocks. I remember having a conversation with Terence, the other day when we were talking about EIP 4844 in PEEPanEIP, and I think at the time it was 2 blobs per block. Now it is 6 blob per block. And I suppose it is mentioned that it is WIP. So does that means that before Deneb we can see a change on it? And if so, what is the factor that is deciding this? What should be the maximum blobs per block?
Right. So the 2 blobs per block would be the target. So there is a max and then there is a target, right? So max, for example, earlier was 4 and the target was 2. Now the max is 6 and the target is 3. What it really means is that if you go beyond, if a particular block goes beyond a target of, for example, 3 right now, then the data gas for the next block will be pushed high, so that basically less and less, so that it will de-incentivize for someone to include blobs for the next block. So what it really does is that it tracks what is the excess data gas that has been trickling down from the previous chain, from the parent chain, and then it prices how much basically fee one would pay to include the blobs. So economically, it's trying to make sure that no more than 3 blobs per block would be included. To the second part to your question, so the concern, or the parameter that will really decide how many max or what is the target limit for blobs per block is latency as well as the bandwidth, because it's not really computation heavy. Computation for making sure that the blobs are correct and everything is in line is quite cheap. But what will really affect, and the disk requirement is not really that high. It's about, for example, 100 GB as of now. So if you keep packing with the max blobs per block for about 19 days, so, and that is again a transient, so it's not really that it will, so it's the one-time allocation that the clients will do on the disk space, right? So it's not, that is also not really a big decision factor. The big decision factor is the bandwidth that will be required, because if you are doing P2P gossip communication between the clients, so you are not transmitting blob one time, maybe you are transmitting it 50 times or 100 times in a particular slot, depending upon what is the number of peers that you have and what is the request response traffic that your client is experiencing. So that will basically, that is a determining factor, as well as what is the delay in which you have block and blobs. So what is this latency from the start of the slot in which you have all the block and blobs, which again sort of depends upon what is the bandwidth that is available to the clients. And then how does the proposal and attestation schedule follow? So there are 2 things. One is block proposal and attestation schedule. And then the second thing is the decentralization in terms of what would happen to small stakers who might not have the resources that are needed to basically support the bandwidth. So I think some testing is going on over this to sort of simulate this particular situation, but whatever the testing teams do it's not really perfect to what one might experience on mainnet. So hopefully when it will be tested on bigger test nets like GoEarly or Holsky, which is the new testnet to be launched with twice the number of validators on mainnet. So hopefully with these bigger testnets, we'll be able to come to a point where we can say that okay, this is what we are experiencing, and maybe we can lower or up this particular limit. But from my feeling in the community, people will try to push the limit down back to 4 per block.
Right. But I'm just curious, like as a client dev, how comfortable you are with the limit getting changed at the time of public testnet? Would it make any effect on the spec of a client, like heavily affecting them?
So right now, I mean, this change from 4 to 6 has sort of, made all client team aware that, this is something that can change, and everyone has basically everyone must have configured their code in a particular manner that it should not be a big deal to change this particular number. And again, on the DevNet 6, we are seeing things getting broken when this change has come in. So most likely clients would be able to handle this particular change in the builds that you just update a particular constant and it gets reflected everywhere. What will really be interesting is the real network mainnet situations in which, how much the small stakers will be able to afford. What is that limit that small stakers will be able to afford? But with respect to development, it should be easy after DevNet 6.
Interesting. Yeah, I have seen like proposal getting out of the grid a few days before the upgrade. So kudos to client development team that they are taking care of every possible incidents to come up and make the changes as needed. My next question is with respect to the extra validation address for blobs. Can you maybe explain that a little bit more? Why do we need that? And how is that going to be very helpful to users or maybe new validator?
So these validations are, just to make sure that the testing surface is low. Because this as of now is big change in itself, right? So there are many things that have fundamentally changed. No one really wants to increase the testing surface. So as such, it should not really impact any of the stakers, but it's more like, we are trying to reduce the testing surface for ourselves, making sure everything is nice and packaged. And so that all the client teams, so there is less possibility of consensus breaking between client teams. But as of now, I don't think, the stakers would be affected in any way.
Okay, that is good to know. One other question I have is with respect to the improvement. I understand there would be a trade-off of all these changes coming in. Is there any feature that you would like to highlight which has been introduced to maybe make a user's experience even better? Or will there be a feature which is going to be affected that it was there earlier, but because we are proposing these changes, it's going to be not available anymore?
Yeah, so one thing that is there is that you can't forward sync before if you start before this blob availability window. So that is something that really needs to sink into the community. That, for example, if you shut your node down for 90 days, you will need checkpoint sync to sync forward. And then you will also need to allocate some of that space for the transient blob storage. And then there is concern for the bandwidth. But apart from that, I think we should be good.
Right. This checkpoint sync will be important for new and existing validators, right? Very well. We are coming towards the end of the conversation. Do you have any message for the validators community?
The message for the validator community would be that, we need to sort of come to a point where we can do PBS, because that would sort of enable the clients, enable the stakers to basically keep this bandwidth requirement in check, and basically not really have to propose or build the blocks themselves, and to basically get involved in this blob P2P communication. So if it can be minimized, I think it will be very important for the small stakers and home stakers and for the decentralization. So that is a point I think is quite important and should be solved or addressed going forward.
Yes, well said here. Just for people who are listening to this conversation, we do have an episode on PBS recorded earlier. So please check out the link in description if you want to learn more about this concept and what changes it may bring for future of Ethereum blockchain. Gajinder Singh, on behalf of the Ethereum community, I appreciate you taking out time to provide an overview of Deneb spec changes. We look forward to seeing proposals moving along the EIP process and being deployed on the mainnet with the Dencun upgrade. On this note, thanks to all our YouTube viewers and ECH podcast listeners for following this episode on Dencun. Check out the links in the description to learn more about this upgrade. Should you have any question on this or any other topic, let us know at eCatHerders Discord. Next week, we'll be back with another interesting talk. Till then, keep sharing your love with Ethereum cat herders. Thank you.